Hey, what's up guys, and welcome back to the channel. In today's video we're going to be going a little further into our C crash course. So this is the second main part of the crash course, and I'm just going to kick it off with some macros. So you can see I have a little code here, but you might notice that sum constant and double are defined in a peculiar way. So double actually looks like a function, but it's not. It's a macro, and so is sum constant. So there's two types of macros you can make. You can make something like an expression macro, and then you can have this constant type expression macro. So when I can define it using a preprocessor directive, hashtag define sum constant 1, 2, 3, 4, 5, 6. And when I do that, if I use sum constant anywhere in my code, what the compiler is going to do is it's going to recognize that sum constant is just a macro, or rather the preprocessor is going to recognize sum constant is a macro, and before going further into the compilation, it's just going to replace whatever was there with whatever I defined my macro to be. So right here, 1, 2, 3, 4, 5, 6, it's just going to replace it with that, and it's going to compile exactly as if I had that. And then the same thing for double. So double, you can see, takes in this argument x, and then it multiplies it by itself. That's actually not doubling. That's squaring. I'm going to fix that. So it multiplies it by 2, and then, so this, I'm passing an a, right? It'll literally just compile to exactly that. Now you have to be careful when using these macros, because you can mess certain things up. So let's say I have an int c, right? And I'm going to be using a function that I haven't told you guys about, but I'll talk about it at the end of the video. All you need to know right now is that it returns a random number. So let's say I have rand, right? And I want to, let's say I have a new macro called square x, and then this will return x times x. So let's say I want to get a random number and square it. So I do this. Now there is a slight problem with this, and I can show you when I hover over, is that since it just takes whatever you pass into square and then just replaces it in this expression, it's going to actually compile to rand times rand. And the problem with that is it's going to be calling this function twice, and that means we're going to be multiplying two different numbers, which we don't want to do. So that's one thing you have to be aware of with macros. It won't happen with functions, because with functions it'll pass in the exact value, or the whatever value gets evaluated from this function. But you have to be careful when you're using macros to make sure when it expands it actually does what you want. So if I ran this example, if I print out a and b, you would see 1, 2, 3, 4, 5, 6, and then you would see whatever a times 2 is, which is exactly what these macros do. And the next thing is structs. So structs are a useful way to not combine, but organize data. So they make basically a structured data type. So you can have you assign a name to the struct. In this case, it's a person, and then within that struct you have many different fields. So if you've ever done object-oriented programming, this is kind of like that. It's not necessarily object-oriented, but it's just a way to group together a bunch of data into some cohesive unit. So in this person, I create an unsigned car age, which will just be 1 byte integer for the age, because I hope no one is living over 255. And for name, it'll just have a string. So that's our character pointer, or it could be const character pointer. So I can create a struct by saying struct, then the name of the struct, and then obviously like any other declaring any or defining any other variable, I just put the name, and then I can send equal, and then I can use this this initialization syntax where I have these curly braces, and then I can just add my name because that's first, and my age because that's first, and then my name because that's second. So you can see that will initialize to name and age. I can also do this if I want to, if I want to be more explicit with what I'm initializing, I can do this, and I can do .age equals 18, comma, .name equals Joe. If I want to be more explicit about which exact fields I'm initializing. So really what a struct is, it's just a block of memory with offsets in that block given a name by you, and the compiler will just translate that to those numerical offsets when it compiles. So it's really just a block of memory with certain segments for different data. So I can access that data, joe.age and joe.name, by just using joe.age, joe.name. So if we compile, you'll see this is what his age and name is. And we can also modify that data. So I just changed joe.name to changed, and then we can, you've seen it already, it changed. However, if I make Joe a constant variable, if I make it const, you won't be able to modify anything on it because it's const. So that's a quick tip. If you put const on any variable, it's not going to be able to be modified, or on any type rather. So then next is a typedef alias. So right here I have a typedef statement, and what this does is it takes the first type you give it and it just creates an alias for it with the second type, %t. So if I don't want to write out this and I instead want to write %t, I can also do that. If I control click, it will bring me back to this definition. If I control click again, you can see it references struct person, and I can also prove that by doing abc.name, the IntelliSense shows up. After that, we have struct pointers. So since structs are these groupings of data, sometimes you don't always want to copy them around, or sometimes you need to hold a reference to a struct, and that's where we have struct pointers. So it's just a normal pointer. All that's special is that it points to a struct. So right here we've created a pointer to Joe, which is of type %t pointer, right there. And if we want to access one of those fields, we first have to dereference the pointer and then access the property. But since struct pointers can be so common and this syntax can be a little annoying to write, there's a special operator for dereferencing and then accessing a member of a struct, which is this dash and then greater than sign. So if you have a struct pointer, you can use that syntax and dereference and then go access a property or change a property. And I'll show you that these two are exactly the same by running. There we go. The age is 18 in both cases. And after that, we have dynamic memory allocation. So this is a really important one because you're going to see this a lot. I mean, actually, structs are also equally important. But dynamic memory allocation is a very important concept to know, because sometimes in a program, actually oftentimes in a program, you won't know exactly how much memory you need to allocate. Sometimes it's a large amount of memory, so you won't be able to allocate it off the stack. And sometimes that amount of memory changes as the program progresses. So if you need that type of memory, that either dynamically resizing it, or you don't know the exact size of it, or it might be a super large size, you're going to want to allocate it dynamically from what's called the heap. And the heap is the part of RAM which is not in your stack, not in your program data, and not in your code section. So the heap is all that other RAM that's not being used, and you're going to allocate it by using the malloc function, which is found in standardlib.h. This is a very useful library. This is part of the C standard library. There's a lot of useful functions in the C standard library, and this is one of the most important ones to be aware of. So malloc takes in a number of bytes. So let's say I wanted to allocate 6 bytes. I just do malloc and then pass in 6. And here I've just passed in the size of int, which is, we can see 4 bytes. And it's going to return to me a pointer to that memory. So most times you're going to actually want to cast this to an int pointer, but today my compiler implicitly casts it, so I haven't done that. And I'm going to store that pointer that returns to me in an int pointer. One important thing is that if malloc fails, it'll return a null pointer or 0. And if that happens, you want to do some error handling. That means for some reason malloc couldn't allocate that much, or whatever memory you asked it to allocate. And right here, if it returns null, I just exited the program with an error code, return 1. But after that, we can use our memory as if it was any other pointer. So I can dereference that pointer and assign the value at that pointer. So whatever memory allocated, I'm assigning 1, 2, 3 into that memory, and then I can print whatever's at that memory by dereferencing it. So if I compile and show you, we can see that at int mem there's 1, 2, 3, and malloc also has some like brother functions, I guess you could say, which are pretty related to it. So calloc is literally just malloc, except it zeroes out the memory. So whatever pointer it gives you, all of the memory that you allocated will just be zeroed out. And realloc just takes in a pointer and a new size to allocate, and it'll try to extend the memory that you've allocated from a previous calloc or malloc. And last is free. So after you're done using your dynamically allocated memory, you have to free it so you don't cause what's known as a memory leak. A memory leak is when a process allocates memory and then never frees it. So it's always holding that memory. And you want, even after it exits, so you want to free all the memory that you can. So if you don't need a dynamic memory anymore, then you want to free that pointer, and you want to do so that you can use that later. Other processes can use memory if they need to, and just overall keeping everything clean. Next are 2 functions, abort and exit. So abort just exits the program with an error code. This is also found in standardlib.h, and exit does exactly what it says, exits and it takes in a code, and that's also in standardlib.h. Another thing is function pointers. So this is a useful concept. So it's important to know that functions are just, like when I type in, I have a function up here named func, and if I referencing this label, func is just a pointer to the start of this code. Right? When this is compiled to machine code, func is just a pointer. It's just a memory address that points to the start of the code for that function. And so that means I can assign it to a pointer. And that's where the idea of function pointers comes in. All I have to do is provide the signature function or func, whatever I'm assigning to. So it's a void returning, and it takes 1 integer argument. That's what I've done. Void, and then we have this star here to signify it's a function pointer, and then obviously it takes in 1 integer argument. I don't actually need the x. I can do it like that, but I kept the x. It's just nice to have for this IntelliSense. And then I can call, since functions are just a memory address, I can call it like any other function. So I can just do this and pass in whatever I want. And when I'm assigning it, I don't actually have to take the address of function. I can, but since functions are just memory addresses, I don't have to. The central line is, or the central thing to know is that this is compiled to the same thing as this. Like this and this are semantically equivalent. And if I dereference this function pointer and called it, it's also semantically equivalent. I could do either or, they'll both work. I just prefer this type of syntax because it's much cleaner in my opinion. But if we run it, you can see that it indeed did go into that function and printed the correct value for x. So there are a number of other useful functions in standardlib. There's a lot, or it's standardlib.h rather. There's a lot of functions to convert from strings to numbers. Those usually start with the ATO. There's str2. These are all functions like str2. And then you see there's a list of functions here. These are all the functions that convert from strings to different numerical types. There's a lot of functions to do that help with data structures, like qsort helps with a data structure that performs a quick sort. bsearch will perform a binary search. I talked about rand earlier, so rand returns integer from 0 to rand max, which is this number, or it's actually system dependent, so whatever is on your system, whatever rand max is. And then there's getEnv. So this is a useful function. It gets an environment variable. So you pass in the name of the variable, it gives you the value. There's system, which you actually just executes a command, so, or like an executable somewhere. So if I run this, you can see it said hi because I just echoed hi. So that's what system does. It just passes this to a command processor. And then there are a lot of functions that help with like multi-byte characters. I'm not going to get into those though because they're a little weird. There's div. There's div. I'm like Python's consuming me. There's div, which actually performs division, but what's special, you can perform division like this obviously. What's special is that it returns a div t. So if you wanted the remainder and the quotient of one division operation, it actually gives that to you, but it performs one singular instruction to perform this division, so it's faster than taking the remainder in one instruction, like using modulus, and then the quotient in another instruction. So it's faster than just doing those. There's absolute value. That's pretty self-explanatory. And there's stuff like addExit, which takes in a function pointer, of void returning function with no arguments, and this actually performs, or this executes the function at when the program exits, which is pretty cool. But yeah, there's a lot of useful functions in standardlib.h, and there's a lot of useful functions in the rest of the C standard library. And so there's a lot of documentation online. You should definitely go check it out to see if any of those functions meet the needs of any of your projects if you're working on some. But that's it for today's tutorial. That's it for the second part, and I'll see you guys in the next one.